All right, let's take advantage of our technology. We are going to now do a confidence interval for a regression slope on this data. So do a quick pause, enter this into your calculator. It's just one big list. So make one big list of the miles. There's 16 of them altogether. And then in order, the same order, a list of the prices so that we can check and make sure things are going okay. Okay, I hope you have paused and put your lists in. Here we go. Let's construct and interpret a 90% confidence interval for B1. Define your parameter. That in this case is the population regression slope for all possible price and mileage combinations for this particular type of vehicle. We don't know that because we don't have all the information for all the cars. That's why we're estimating it. We have conditions to check. Let's run through our liner steps. Starting with, do we look like we have a linear set of data? Well, let's take a look at a scatter plot. I'm going to turn it on. I want L1, L2. And then just do a zoom 9. I think I had another plot on that I'm going to turn off. Okay, does it look linear? Yes. So we are in good shape there. Next, the I. Are we independent? Well, we looked at 16 vehicles. We have to be able to assume it's reasonable there are at least 160 that are for sale. I think that's going to be reasonable because we don't really have a choice otherwise. I don't know how many Ford F-150 Super Crew 4x4s there are out there, but let's assume there's at least 160. Next, the N. This one's tough. So this is where we're going to look at a histogram of the residuals. To get the residuals, you first need to run a linear regression. So stat, calc, I personally like number 8. We want to do L1 and L2. All right, L1, L2. Nothing for frequencies. We don't need to store a regression equation. Let's calculate. Okay, I don't really care what the regression is. I just now have residuals I can look at. So let's go into another plot. I want to do this time a histogram of my residual list. Now that's in your list menu, second stat. If I scroll down, there should be a resid list, all right? And I want to turn off my other scatter plot so I can just use my zoom 9. All right, so zoom 9. Now, what we're looking for is it relatively unskewed with no outliers? Well, I don't think there's any outliers here, but I don't know. I'm going to adjust the picture a little bit by taking a look in the window and seeing what the defaults were, and then adjusting them a little. All right, so negative 8,000. Why don't I take it all the way down to negative 10,000? Just kind of picking a nicer number. And this goes up to about 12,000. Okay. And then how wide do I want my bins to be? I don't know. Let's go by 2,000s. I'm just trying to see if a different picture makes it easier to see what sort of potential skewness there is. Take a look at the graph. All right, this actually looks pretty good. So no outliers. It's not bell-shaped, but it's not super skewed, and that's all that matters. You should make a sketch of this on your paper to show that you've checked this condition. Okay, next up is the E. Do we have essentially the same standard deviation everywhere? Let's look at a residual plot. Let's turn the histogram off, and let's turn a new scatter plot on. I want the X's to be L1. I want the Y's to be the residuals. And let's see what we got. Yeah, this looks roughly spread out about the same the whole time. I certainly don't see a fanning effect happening, so we're good there. And then that's the E. Lastly is the R. We were told this is a random sample, so we're good. Conditions are met. So write it. And I would include these sketches myself, a rough sketch of the residual plot, scatter plot, and histogram. Because there's so many graphs, it wouldn't hurt to label them. Now, when it comes to the actual confidence interval itself, we're just going to let the calculator do it. If you go into your stat menu, over to tests, all the way toward the bottom, there's a linear regression t interval. We just need to tell it, I want to go L1, L2. Whoops, L1 for the X, L2 for the Y. Leave frequency at 1. Don't ever change that. And confidence level, I got to remember 90%. Okay, so 0.9, that looks good. Calculate. It's going to think for a little bit. And there you have it. Our regression slope, 90% confidence, is between negative 0.2174 and negative 0.1084 at 14 degrees of freedom. I would personally include the degrees of freedom there because sometimes they want to see that. All right, and then interpret. With 90% confidence, the true slope of the regression line that relates the miles to the price. So for these cars, it looks like, because these are negative, as miles goes up, price goes down. Include a unit on there. We are looking at dollars per mile because the Y's were in dollars and the X's were in miles. So again, that's in your linear regression t-interval. Put in your list and set your confidence level. You should be all set.